All right, so we got Unit 3, Lesson 2 here. Just kind of going over how to analyze quadratic functions, Part 1, in terms of, the form, how we want to look at them, what's general, what's standard, and all those kinds of things. And we're going to go through quite a bit of investigation, so it might be a little bit longer. Okay, if you're watching this to catch up, they're kind of repetitive, so if you don't want to watch the whole investigations, you're welcome to fast forward since it's a video, so that's kind of nice. Okay, so quadratic function is a function which can be written in the form of ax squared plus bx plus c, okay, or in the form of y equals ax squared plus bx plus c. They're saying the difference is a isn't 1 or a is 1, so we've already seen those. That's our general form. Okay, that's our general form right there, ax squared plus bx plus c. Okay. Okay, so again, this is just kind of repeating, and then make sure we understand, this comes back to what we've already learned. This part right here, they're just making sure you remember that we know that this quadratic equation will have roots, zeros, or could, I guess I shouldn't say we know, okay, or roots, zeros, or x-intercepts. And we can find those by solving using factoring, the zero product, all that stuff. Okay, so that helps us figure out. Remember, what do they mean? The zeros again are where the parabola crosses your x-axis. Okay, so you have three options. I'll put these three options up here, and this is for future. You have 2, 1, where it just hits at one spot and bounces off, and then you have none, where it doesn't cross at all. Okay, so those are kind of your three main options for roots, zeros, when we're doing these quadratic equations for this unit. Okay, so we come down here and we're going to get into general and then standard form. So general is the one we're used to. This is the one that we factored, ax squared plus bx plus c. Okay, so we're very used to that. Standard form is a little bit different, and this is more, I want you to write on here, this is more graphing friendly. Okay, we can do graphing is so much easier because standard form gives us the vertex, which we've already talked about, the stretch, okay, and the possible reflection. Okay, so here we go. Okay, in this unit we'll study both general and standard form, beginning with the standard form in this lesson. So we're going to start with standard form, and we're going to kind of just talk about what each piece of it means. So the first thing we're going to do is we're going to look at the graph of y equals x squared. Okay, so all we're going to do is we're just going to fill this chart. It's kind of tedious, but just -3 squared is 9, -2 squared is 4, -1 squared is 1, 0, 0, and then back. Okay, that makes sense because it's a parabola, so that's the bounce, that's the bend. So when you're graphing it, it should look something like this. And here we go. Like that. So that's just your standard parabola. Okay, this is the axis of symmetry. Is the mirror line which splits the parabola in half. So you can see it right down the middle, the y-axis in this case, is the axis of symmetry. Okay, the axis of symmetry is always going to go through your end point there, your vertex point. Remember, that's your vertex. Okay, so that's your axis of symmetry. So that's what I just kind of jumped the gun here. So the vertex, okay, is the lowest or highest point of your parabola. Okay, and it's where your parabola changes direction, because your parabola has to change direction because it's a square. So at some point, it's going to mirror itself because it's either going to be all positive or it's going to be all negative, depending on your reflection or not. Okay, so that's why this is your vertex. Your axis of symmetry goes right through it. Okay, see, it represents your minimum and maximum point. Okay, so we want to label, like it says, we have this V. We're going to call that AOS right here, axis of symmetry. Okay, and moving forward here. Okay, the maximum value of a quadratic function occurs at the vertex and is represented by the y-coordinate of the vertex. This is very important. People continue to forget this. Your y-coordinate of your vertex is the is the max or min value. Okay, so for example, the minimum value, because the one that we just looked at there was a valley, so If it's going up like this, it has a min or a valley. Okay, if it's going down, it has a hill or a max. So the one we just did is a typical x squared is going to be a min. Okay, and the min for this one is at 0 because it was at 0, 0. That's where our vertex was. Vertex for that point up above was 0, 0. Say the domain and range of the function. Okay, there is no limitations on what my x can be. If you look at your picture, you have a probability of doing this. There's nothing that's stopping it from going this way or this way. So your domain is all real numbers. Okay, all real numbers. Okay, your range, there is a limitation. It's a parabola that starts, the minimum is at 0. So if the min's at 0, that's the smallest it can be. So x, or excuse me, not x, range is y. Let's make a note of that while we're at it. So domain is your x, range is your y. Okay, my y is greater than or equal to 0 because it's 0 is the smallest and it goes up. Okay, nothing negative essentially is your y. And that makes sense because if I square any number, I can't get a negative. It won't happen. Okay. All right, let's move on. Take a little bit look at the transformations now. All right, so analyze functions with standard form. So the a, x minus p squared plus q when a is 1. So we're going to first look at, on this first investigation, we're just going to look at how q is, what kind of transformation q makes. Okay, so when we're going through here, we're going to see that we're going to take the original x squared graph, and then we're going to add a q to it. Okay, and so all this means, and don't be confused by this f of x, it's just function notation. And so it's just saying, if f of x is x squared, then y equals x squared plus 3. We're just taking this x squared and we're putting it where the f of x is. So don't let that get confusing for you. Same thing here, x squared minus 3. Okay, so that's the equation that represents the following. So use a graph calculator to sketch them. So if you put them in your graphing calculator to save time here, I'll show you what's going to happen. So the x squared plus 3, it's going to move it up 3. Right here. And it's the same pattern. 1 is 1 squared. 2, I'm going to go up 4. Let's see. 2, 4. Negative 2, 4. And then here's my parabola after it's shifted. Okay, and then if it's minus 3, it's going to move this point down 3. 1, 2, 3. Same thing. Over 1, up 1. Over 2, up 4. Over 1, up 1. Over 2, up 4. You can see they're mirrored because they are symmetric. Okay, so we kind of just saw that the q affects up and down movement. Up and down movement. Okay, all right, let's check out this chart here, and it's going to kind of further, make it a little clearer, I guess, if you will. Okay, so when we had y equals x squared plus 3, so that would be this. And then this one will be y equals x squared minus 3. And then we want just the general x squared plus q. What does that mean? So the vertex did move. Okay, we did move the vertex. We moved it up 3 on this one, so it changed my min to a 3. This one moved down, so 0, negative 3, so it changed my min to a negative 3. And then we just, the pattern, you can see negative 3, so I'm just going to, it's just 0q. Is your vertex. In this case, it'd be a min at q. Okay, our axis of symmetry doesn't change because we didn't have any left and right movement. That y-axis is still our axis of symmetry in this case, which represents that as a line of x equals 0. The reason being is because, remember, vertical lines are x equal lines. Okay, because when I have my, let's do this with a different color here. Okay, so if I wanted x equals 2, it'd be 1, 2, a dot at 2 on the x, and I'd go through it. So all vertical lines are represented as x equals. And x equals 0 looks weird because it's going right down a line that's already there. Okay, but that's the deal with that. Okay, so then it says blank translation, blank units, blank. So it's a vertical translation, 3 units up. This one was a vertical translation, 3 units down. And then same thing, vertical translation. Q units up. And obviously if it's negative, it's down. Okay, what is the effect on the parameter of Q? Okay, so the graph undergoes vertical translation. Of Q. Okay, and just compare to the graph of y equals x squared. The graph of y equals x squared is plus Q results in a blank translation. Okay, again, that's vertical. It's being repetitive. It's really trying to get you. Q is vertical. Okay, Q is vertical. So if Q is greater than 0, the parabola moves up, positive. If Q is less than 0, it moves down. What if Q is 0? And it doesn't move at all. Okay. Okay, let's go into investigation 2 here. It talks about left and right movement. Remember, this is all from standard form, so we're kind of building the standard form. All right, so looking at investigation 2, let's analyze the graph of y equals x minus p squared. The graph of y equals fx x squared is shown. So again, it's giving you function notation, and so this means put x plus 3 where the x is. So what that means is you're going to have x plus 3 squared, like that. And it's the same thing over here. I'm plugging in the x plus 3 for the x, so I'm squaring x plus 3. So this one's the same thing, but with x minus 3. Okay, and what this does when you put in your graphing calculator, okay, this one, we'll do in red, is going to be moved left. And it's the same graph, 1, 1, 2, 4. It's just been shifted left. Okay, we'll do the other one in blue. This one moves to the right 3. 1, 4. Okay, and the reason that happens is because this is our 0 property. What makes this 0 inside? A negative 3. Back to what we've done with factoring. What makes this 0 inside? Positive 3. This describes the movement. Okay, so this being a negative 3 is why it moved left 3. This being a positive 3, that's why it moved right 3. Okay, and we just did that. Okay, let's get to our table. Okay. All right, so again, we're going to write it here. So it's going to be y equals x plus 3 squared, y equals x minus 3 squared, y equals x minus p squared. So the vertex did move, but not vertically, so we keep the 0 on the end for all of them. Okay, but this moved to left 3, so negative 3. Second one moved right 3, so positive 3. So then we know that it's going to be opposite of p, okay, or whatever p is. Okay, it's going to be the opposite. That's what I was telling you guys. Always think of it being the opposite. Okay, very good. All right, so then we have min is 0. So this one, we're going to have the min's going to be 0 for all of them because we didn't move up and down at all. But we did move left to right, so now our axis symmetry does change. If you go back up to those pictures, it's going to be, in this case, your axis symmetry is always going to be your x value. So x equals, x equals negative 3 for that one, x equals 3 for this one, x equals opposite of p. Okay, and so we have a horizontal translation, 3 units left. Okay, and this is the same thing. I'll just use these quotation marks here. 3 units right. Okay, and then we'll say same thing, horizontal translation, and it'd be p units, whichever it is, positive or negative, but they say right just for right now. P units right. So what's the effect of the parameters? Again, the graph undergoes horizontal movement. P units. I'll just leave it P units. That way you can just say if it's negative P, you can move left. I'm not going to say P units right there. Okay. Compare the graph y with x squared. The graph results in a horizontal translation. Again, just kind of hammering the point home. So P affects your graph horizontally. Okay. This right in there. P of the standard form. Got one little piece here I got to move up and get. Okay. So if it's bigger than 0, if P is bigger than 0, it moves to the, remember we're thinking opposite. So if P is bigger than 0, being the opposite, it would move left. And if it's less than 0, it would move to the right, because we're thinking it moves opposite. So what I'm saying by that, just because I'm doing a little bit different in the book, if you have x minus 3 squared, that to me is less than 0. Okay, so we're moving right. That's this one. Okay, if I have x plus 3, we're moving opposite. We're moving left 3. Okay, that's how I'm kind of translating that for you. Okay, we got one more investigation and a couple examples and we'll be done. Okay, so investigation 3. Analyze a graph of y equals x minus p squared plus q. So now we're putting them together. Okay, so this is write the equation that represents. So I want you to stick x plus 2 in there and b squared and have a minus 4. So the equation would be x plus 2 squared minus 4. Just predict the transformations and then use your graphic calculator to verify. Well, we just learned that this plus 2 means left 2. And then we learned before that down the end is our vertical, which would be down 4. Remember, opposite movement here, normal movement here. Okay, let's fill out the chart and see how we do. All right, so x squared, 0, 0, okay, so that's just the standard table. So this one here, the equation would be x plus 2 squared minus 4, y equals x minus p squared plus q. All right, so this one, the vertex, we had 2 movements. So we have 2 things. The vertex is going to move quite a bit. It's going to be negative 2, because opposite of here, okay, and negative 4. Okay, it's still a min, and it's my y value, negative 4. My axis of symmetry did move. It is negative 2 now. Okay, so we moved vertically down 4, horizontally left 2. Okay, and so again, here we go. This one would be opposite of P, so in this case it would be a positive P, Q, min at Q, X would be P. Okay, and then it's same thing vertically Q, horizontally opposite P. Okay. All right, so we're going to do a couple quick examples here, just going through the movements. Okay, just going through the movements. So let's do these, and then we'll be done. All right, so this one here. So describe the graph the following functions relate to the graph y equals x squared. So we're describing the movements. Okay, so this right here only has a movement right there. That's inside, that's a P, so plus 10 we want to move, it's going to move left 10. Okay, so it's a horizontal movement. Okay. Okay, well, x squared plus 4. So that means I'm going to go up 4. That's my Q. Okay, so then that's vertical movement. Okay, this one's issue is I need y by itself. So I'm going to minus the 8 real quick. And I'm going to have y by itself, and I'm ready to go now. Okay, so I'm going to have 2 movements. I'm going to have right 5, so opposite, and then down 8. So it has a horizontal and vertical movement. Okay, very good. All right, it says for example 2, the following transformation are applied to the graph y equals x squared. Write the equation of the image function for each. Horizontal translation, 5 units right. So I know if it's horizontal, I'm going to be dealing with something in here. This is my horizontal movement. If it's 5 units right, think opposite. Right is positive, I want to minus 5. That's it. Y equals x minus 5 squared. Okay, a translation of 6 units down and 4 units left. So I have 2 now. So I'm going to have y equals, I'm going to have a movement in here, and I'm also going to have 6 units down. So I'm going to have a minus 6 out here. Okay, so the inside is 4 units left. So the opposite of left would be positive, so plus 4. So there it is. Y equals x plus 4 minus the 6. Okay, and our final example. Write the coordinates of the image of the point 3, 9 on the graph y equals x squared when a translation of 2 units up and 7 units is right is applied. So all I have to do is understand that 3, 9 is a point, x, y. Okay, I'm translating 2 units up, 7 units right. Okay, 2 units up affects the what? It affects the y. So that's going to make me go, if I go 2 up, that's going to make it 3, 11. Okay, and I want to go 7 units right. So 7 units right, I'm going to add 7 to 3. So I get 10, 11. So your new point would be 10, 11 for that specific problem. All right, well, that's Unit 3, Lesson 2. All right, thanks.